Let's just check if it's recording. Check, check. Okay, so we're now into the Python and Pygame portion of the lesson. So let's just swim through this one. So again, my PowerPoints, if you've noticed, I'm just going to mention this. I've kind of fast-tracked you, okay? My PowerPoint's always going to review stuff we've already touched upon. And the reason for that is, well, except actually until we get to our further frameworks, right? The reason for that is because I'm kind of showing you how to do it, and then I'm talking more about it afterwards to give you a chance to kind of consume it a little better. So in this particular case, again, we've already touched upon classes. We've already talked about functions. We've already done this kind of stuff. So all we're doing is kind of going into more detail about this, reviewing the stuff that we've already seen before. And then we're going to talk about this paint.py program that you're going to use as the basis of your assignment number 3. So let's take a look at that. So here's paint.py. Here's what paint.py doesn't do, if you notice. Paint.py does not use classes right now, right? Paint.py uses a strict non-classed or function-based code, okay? So it uses a couple of different functions. If I go to the main function here, right, I start off, here's my initialization, right? I set my screen width to 640 by 480, right? And I actually set my caption here to paint. And then I have some kind of instructions, R for red, G for green, B for blue, and so on. I'm putting this all in my title bar, okay? And it actually shows you if I want to change the width of my pencil, I can just hit the 1 to 9 key, C for clear, S for save, and L for load, right? So all these functions right here, I'm basically telling you on the title bar what all these functions are going to do. I'm setting up my background, my surface for Pygame, and it's going to be the size of my screen. So I'm just calling it here background. But it could easily be called surface, or it could also be called frame, whatever you want to call it. It's the same concept we just reviewed with Tkinter, right? So the first one, again, the first surface is your top level window, right? And now you're creating a background. And in this case, the top level window for Pygame, right, is called screen. Okay, here's your screen. This is right here. Oops, there. Screen is your top level window. Background is your subcontainer. All right, subcontainer. And if you notice, right, background is another surface. Now, right now, it's a surface within the screen. Right, so it's going to be layered on top of the top level window automatically in Pygame. Yeah.
Aren't those both technically objects?
Which ones?
The screen would be an object.
Screen is your top level window, right? Screen is your top level window. It's almost like the window that has all the control bars, that you might have your X on the window and all those kind of things. That's what screen in this particular case represents. Once you do this Pygame.display set mode, right? That's your top level display or top level window in Pygame.
No,
right?
I know, but I just mean you said it was an object, right?
Oh yes, they're all. But I'm saying they're all objects. We're using objects that exist. But in this particular case, the methodology here, we're not using classes, our own custom classes. We're just using the class that exists in Pygame, in Python and Pygame, and we're not using. It's a flat architecture when we do this code. There's no classes that we go to. We don't instantiate a class and then use the methods of those classes. Here, we're just using functions that we're going to create, right? So this is a very simple example. Okay, so we got your background, which is your frame. I'm setting up my clock, right? So I'm initializing my clock. Here's my sentinel variable. Keep going is equal to true, right? And then I'm going to set up a couple of variables that I'm going to use for my code. Line start, so 0, 0 coordinates, and my draw color. This would be your another RGB. This is what this is going to accept, a list of variables. This is going to be black right now, okay? And my line width, my initial line width for my drawing is 3. So 3 is the width of my pen in pixels. All right, that's what I'm initially setting up here. And now here's my game loop. So while keep going is equal to true, clock tick 30, so I'm saying 30 frames per second. So every 30 times a second, I'm going to be checking, I'm updating my screen. That's what I'm going to be doing over and over again. And now here's my event loop. So for event in Pygame event get, and Pygame event get, if you remember from my videos, if you actually watched them, or if you read your books, Pygame event.get method, actually what it does is it says, I'm listening for all events. That's what I'm doing, okay? And now I'm saying if my event type, I'm using the type method on the event class, right? I'm using it to say if my event type is equal to quit, then my keep going is equal to false. I'm going to break out of my loop. That's what I'm going to be doing, right? Otherwise, if it's mouse motion, so if I'm moving my mouse around, right? What I want to do is I want to get my position, my mouse position. So my line end, I'm creating a line end variable, is going to be equal to the current mouse position for this frame. Right? Every frame, I'm going to update this variable, this line end variable. Okay? So it's going to be giving a new set of coordinates, a tuple that's going to be given to it from my Pygame.mouseGetPosition method. Okay, that's what it's going to be getting. So that's what the line end is going to be receiving. Yes?
If you just do it one from, that's button up.
You could, but what I'm saying is here, you can do whatever you want, right? But here what we're doing is line end, it's tracking wherever my mouse is going to be every frame, so it's very accurate, right? I can track it every other frame. I can track it every 10 frames. I can never track it, right? It's up to you. This particularly, it's listening for my mouse events, or it's actually reporting my mouse position every frame. That's what this is doing, okay?
Line end is like mouse position.
In this particular case, yes. If Pygame.mouseGetPressed, now I'm checking a different kind of event, right? If my mouse is pressed, and then if you notice, 100 is the type of event handler I'm listening for. This is basically showing my left mouse button, 100. If it was here, it would be my middle mouse button, and if it was this one, it would be my right mouse button.
So it'll do 001?
Correct, right? You can actually have more than one mouse press all at the same time too, right? Multiple mouse presses it can listen for as well, right? But if my mouse get pressed event is equal to left mouse button, that's what this is. And by the way, you can create this as your constant that you were talking about. So I can say constant left mouse button is equal to 100, right? You could do that to make it more human readable if you wanted to do that to make it easier for you, right? So then I'm going to draw a line. I'm going to draw a line. So Pygame draw line. I'm going to put it on top of my surface called background. That's going to be my parent container for my line, right? I'm going to draw it in a particular color. And if you notice, my color right now is black, as I said over here, right? And my line start is going to be 00, top left corner of my screen, right? And my line end is wherever my mouse is at that particular moment, okay? My line width, right, as an example, is going to be whatever it is. So right now, my line width is 3, okay? And now what I'm going to say is my line start is equal to my line end. So wherever I've repositioned my mouse now, it's going to keep track of my line start and my line end, right? And it's going to keep track of both of these two values as I move my mouse around. Similarly, I'm also going to be listening for key down events, right? So depending on the type of event I get, I'm going to go to, I'm basically going to say it's equal to my data is going to be, and this is a great way of doing it, by the way, guys. If you look at this is very Pythonic, okay? Pythonic. My data is going to be a list of different variables all together. Event, background, draw color, line width, keep going. Those are all different event variables that I'm putting into one little variable called my data. Okay? And I'm going to pass all those variables all at once into check keys function. All right? Here's where it passes into the check keys function. All those variables and the list of variables are going to be packed together and compressed and put them all inside this. They're going to be passed into the check keys function, and then they're going to be passed back out into my data. This is the way to do it so there's no global variables. Right? Make sense?
That would have been helpful.
Okay. And then what you're going to do is you're going to say that not only are you passing them back, but you're also passing them, you're reassigning them now. So this line here, take a look. This line here, so I've got them back here, right? And now I'm redistributing them from here reassigning them back out to the other variables. This is the way to do that. So I'm passing them in and passing them out. Okay? So instead of me passing more than, I'm passing all of these things into my my check data, my check keys function. We're going to see that. Then I'm going to spit this. I'm going to blit the screen back onto the background container, which is my main frame, right? Which is inside my top level window. At 0, 0. That's the top left corner of the screen. Starting at the top left corner of my screen. And I'm going to create a label. I'm using a show stats method. I'm going to draw the color and the line width in my label, and I'm going to spit my label out at 450 by 450. This is not a particular location on the window, okay? And then I'm going to refresh the display. And that's my event loop, just this. Any questions right there, what I'm doing here? So there's some really nifty variable manipulation in these 3 lines that I really want you to take a look at, because these 3 lines are key for your understanding when it comes to passing more than one variable in and out of a function. Okay?
Is it going to be in the right order when they're going in?
Yes.
The exact same order when they're going out?
Yes. Yes. Or, alternatively to this, what you could have is instead of my data is equal to blah, 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 you could have it so that check keys passes in all these different things. So you take all these variables here, and you put them right here.
And then it would still equal my data.
And then, instead of my data, you put all these other things here, right? All these things here on this side too. So both of them are going to be the double width. You'll have the same variables on the left and the same variables inside of the arguments that are going to the function. You can do it that way as well. Okay?
You can take those 3 lines and make them 1 line.
Yes. But the problem with it is it's not as clear. This is very, very more human readable. Okay, so let's take a look at that check keys function. That's one of the main ones, right? So check keys, if you notice, it takes in one variable, my data. But now I'm going to extract the data just like I did before. I compress the data, and now I'm going to extract the data. And that's exactly what I do later on too. So I do it twice, right? And now I'm saying, well, if my event key is equal to a Q, right, I'm going to quit my program. That's what this is. If my event key is equal to a C, I'm going to clear my screen. I'm going to fill my screen with white. That's what this is doing, actually. It's a trick, right? If my event key is equal to S, I'm going to save. I'm going to use my pygame image.save. I'm going to take my background as the surface I'm saving, and I'm going to save it as painting.bitmap. Remember that painting.bitmap that I used in Tkinter? It's the same file. Okay? We're going to see why I'm going to do this, why I've done this way. Okay? If I use the L, my L key, it's going to allow me to use my load function, right, to load the bitmap back up. So I can load it back into my code as I go. If I press the L button, it loads my image back up in, so I can continue working on it. Excuse me. If I click on red or R, it's going to change my drawing color to red, and so on. It's going to change. These are my color changes here. Okay? And it's a long line of elif, 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 elif. So depending on what I pick, it's going to be one thing that I'm going to pick per frame. Yes? Yeah.
Okay. When you're saving your background surface, how does it know the shapes that you draw on top of it?
Everything is linked. Everything I draw is linked to my background surface. Every shape I draw, the top parent, the top level container for my shapes are going to be my background surface. And it's actually there. If you look at some of these things, there's a line width. I'm changing my line width here. But if you look at some of these other functions that I'm going to be doing, right, when I draw, and my drawing is actually happening inside my event loop here. Here's my draw line, right? My background is my parent container. My draw color is I'm going to get from check keys. My line start and line end I'm going to get from my mouse position. And my line width I'm going to get from my check keys as well. Right? So here's my actual function. This function here draws a basic line. That's all it does.
A straight line or a
straight line? Well, it's kind of crooked, but straight. It'll appear straight to you. How about that? Well, and we'll see why that is. But that's all this does. This function, this check keys function, it basically gets all the different input from your keyboard and then returns all that input. It compresses it and returns it back out in the same compressed format. That's what it does. And show stats, all it does is it returns a label. That's what it is. It's creating a label with a particular font, and it's showing the color and the width of the tool. So let's take a look at how this runs. Enough about analysis. Let's just see it. So here's my screen. Here's my paint.py, and I draw on it. And if you notice, I can draw this way, right? Here's my line. I'm drawing a freehand drawing, because even though the line is going from line start to line end, and my line start and line end is changing as I move my mouse, because I'm listening for mouse movement, right?
So it's painting each 3 square pixel block every frame, or a bunch of times a frame.
Right, because my width is 3, right? If I change.
But once you paint them, it doesn't have to remember those coordinates anymore.
No, it's splitting it onto the screen, and now it's part of my surface, right?
If you're drawing a straight line, that takes it over frames. You know what I mean? It happens over.
No, it actually does the same thing. It does it over frames, but it does it over on the same surface. It just spits it out on the. You'll see it when we do an actual line, like a physical line. We'll do that later on. It does it over that whole surface again. It saves it on the surface, but it does do it over a bunch of different frames.
Yeah.
Okay, and you'll see it'll appear slow, a little slower than this, right? Okay, so let's take a look. So now I've drawn this squiggly diagram, whatever, with a width of 3. If I change my width with my keyboard to 2, right? I just pressed 2. My width just goes down to 2, so now it's a thinner line, right? If I want it clear, I can press clear, right? I can change my color to blue. I can change my width to 6, and I made these changes. If you notice, the color actually changes here just to reflect my changes. And now I can, make my drawing, whatever I want, right? I can make a happy face if I want. Here we go. Maybe a pointed nose, right? Whatever. Maybe a couple of hairs on the top of my head, right? And then if I want to save it, I know it looks rudimentary, okay? But watch. If I save it, right? I'm press the S button. You don't see anything. I press the S button. But it's actually saved my diagram, right? So now I'm going to close it off. I know, it's crazy. Here's, I'm going to close this off. I've closed it. And if I go back to my previous code, which was my painting.bmp, it saves it right here. So if you notice, the save functionality, right, is right inside my check keys. So when I check keys, the same folder that the paint.py code exists. I can put it in a subfolder by changing my path right here. This is my path of my file, okay? But in this particular case, I'm saving my background. This is the surface I'm saving to this file, bitmap, painting.bitmap. Okay, let's take a look. So if I use placegeometry.py now, right? Remember, I use that same thing. And if I load it up, right? Here's my image, right? Because I'm loading that same file up here, right? If I put click me, I can reset it, right? I'm not messing around with this bitmap because I'm using Tkinter to bring up the bitmap that I saved with Paint. Okay? And the same thing, if I go back to my Paint program, I launch it. Okay, right now it starts off blank. If I load it, if I press the load button, it loads it back up. It's hard-coded. Okay? So again, this is some of the rudimentary, the pieces that you're going to need for your assignment number 3. Okay, we're going to talk about the other functions that we're going to add as we go. Okay, so let's go back to the PowerPoint presentation. So again, it gets, like it says here, it gets a bunch of input from the user. So we don't really have buttons at this point. So this is like, there are no buttons or icons that we're going to use to click on to create different pens or different effects. We're not doing that with this code. All right. What we're doing with this code is we're just drawing. All I can do is freehand drawing at the stage. Okay. And it does it in outside of a class. It does it by the check keys function. All it does is it pulls every frame what kind of key I'm getting. Okay. You could use a very similar thing. Instead of checking keys, you could check buttons or check whatever. You can do a check function every frame, right, which I recommend that you do. Okay. We talked about surfaces, image surfaces in Pygame, and one of the ones we did this time, in this particular case, was the background surface, which is, again, like we mentioned, I'm just repeating myself here, and reviewing that is the background is a surface object that layers on top of the top level window or the root object. Okay? We've already used the main function, even though this says using a main function in this code. We've used the main function from the get-go, right? And the reason why I introduced that right away is so you guys are familiar with that. If I hadn't introduced it until now, and I've done this in previous iterations of this of the course, it's a bit of a shock, believe it or not. You have to reorganize everything the way you do things. This way you've already done it with functions. You're already using functions as you start off, right? So whereas you really don't have to with Pygame. You could write one line of code and that would be okay, right, with Pygame, right? But we're not doing it that way, and I've asked you not to do it that way from the get-go because it's so unstructured. Okay? Okay, let's take a look at modifying idea for functions. I like this idea. So let's take a look at main function.py. Here it is. Let's run it. Okay, now I'm using a main function. I can't do anything. All it's drawing is a little square in the middle of the screen, right? But this is the idea. This is how you would layer the idea framework for your function. So you have your main function here, and then you have your idea frameworks in the middle. Okay, he's still doing display and everything else. You're just doing it inside the function as opposed to outside the function that we showed it in the last program, paint.py. It didn't use the idea framework the same way. And we're going to skip by this because we talked about how name is equal to main works. And by the way, again, we're reviewing this in lesson 5, and I showed it to you in lesson 1. All right, so that's what I'm talking about from a fast track perspective. I wanted you to be fast track because you start using that framework now, and now your mind is geared towards creating it that way. I've kind of cheated a little bit, right? Because if you created it the other way, changing your mind to do it this way when you make the main game as you're going forward is much more difficult. Okay. Let's go to drawDemo.py. Here's really, I think, this code here, by the way, drawDemo.py, has the majority of the code that you need for your assignment number 3, right? drawDemo.py. It's like paint.py, right? But it includes a bunch of other functions. So let's take a look at that. Okay. So here we go. There's a function called drawStuff. Okay? So let's go back down to our function here. So again, we set the the top level window 640 by 480. And in this particular case, we're going to have different events, that we're going to be doing. Okay, so again, we're setting up a 30 frames a second event loop. We're listening for the quit event, and then we're listening for something called mouse button up. Okay, it's a type of event. We're also listening for we're going to print out the mouse position. That's what this is going to do. Okay, and otherwise we're going to update the screen. So all this is going to do is update the screen. Okay, but in the beginning it's going to go to this function before we get into this main loop. Before we get into the main loop, we're going to draw stuff. Okay, so it's going to draw a bunch of stuff and throw it onto the basically configure a bunch of little things that it's going to draw, and then it's going to, in memory first, it's going to load all that up in memory and then split it out into the screen. That's all it's going to do. All right, so let's take a look and see what it does. There you go. So you got a square, a circle, a rectangle, different things. It's kind of drawn out here. Automatically, it's throwing them out onto the surface object. Okay? And it does it through a hard-coded view. So here's my line. So here's if you notice where it's going on the background surface. That's where it's going. This is the color, right? This is the beginning point and the end point. Okay, I haven't specified a width, so it's going to take a default width. Okay, and there, if you notice, the default width is equal to 1. Okay?
Is there a little red line on the picture?
It's RGB, right? So 255 would be red. All the color turned up. Right here it is, right here. There's your color tuple, or if you will, right? So RGB. So this is red. And again, the great thing to do, and I would recommend for you to do this, is create constants for red, green, blue, and common colors if you're going to do this. Right? So that's more human readable again. Right? Here I'm drawing a rectangle, here I'm drawing a circle, here I'm drawing an arc, here I'm drawing an ellipse. So right there, all these things are the code that you need, right, to draw your objects, right, when you click on the buttons, right? The challenge is getting the right colors depending on what the color the person has chosen, right, and the beginning and end points. That's the challenge, isn't it? And that's what your code is going to have to do. Here's some lines, and this is an example of of a list of tuples. That's what this is, a list of tuples, right, where you're going to draw a bunch of lines, right? So all I'm doing is I'm passing this whole list into this code called lines instead of line, right? And I'm passing in the hexadecimal values of the colors in this particular case instead of the regular RGB decimal values of the colors. Both work well in Pygame, if you remember from last lesson on the videos, for those of you who watched them, right? Or went through the presentations. Okay? That's all this does. So it's very, very straightforward, but it handles the majority of the code that you need. Here's the polygon, right? Your background and the same points. So it goes through the same points. Here's your polygon points, right? And it's going to draw a polygon with whatever points you have. Right? In this particular case, it's 1, 2, 3, 4, 5, 6, 7, 8 points. Okay? So a 7-sided polygon of some sort. Okay. So you've got your basic code. It does use the idea and alter framework again. All you're doing is you're listening for these different events to happen when you. All you're doing is you're closing this thing off. You're actually either closing it down. You're not drawing anything in this particular case. All this demo does is it draws everything for you programmatically. Okay. And the other thing that we're doing here, this is what it demonstrates, is it actually uses the math module. I'm importing math at the top of my code. So if I go back, right, on the top of my code, I'm not just importing Pygame here, right? I'm importing math as well. And you need that math function or math library for pi if you're drawing an arc, as an example, or an ellipse. Okay? So you can draw an arc or an ellipse in the way that you want. Okay. The chalk that kills me in this class. That's why I have to drink water so often. One day we're going to be more computerized, and I'll have a little, portable whiteboard on the side. Okay. So we talked about drawing a line, and I'm going to kind of fly through these. Drawing a rectangle. These slides here that I'm going to kind of go through. These are the basics of how to draw different objects. And there's going to be a whole library of stuff you can draw. If you actually go up online to the Pygame documentation, there's going to be a library of drawing different objects. This isn't the challenge for assignment number 3. Assignment number, drawing objects with Pygame is easy. Okay, so here's a circle, an ellipse, and so on. I'm going to kind of fly through these. This is important. Common angles and radians. Let's take a look at this code really quickly. Math.py. Do we even have it here? I don't even have it here. Somehow it's been lost. Anyway, but the great thing about it is, and if I don't have it, you don't have it. That's for sure. But basically what it is if you look at your different angles, if you're actually going to change the angle that you're looking at, your angles for moving objects or for vectors in Pygame is all done in radians, right? And going back to math, if you guys remember math, radians and angles and all that stuff, it's not just in like your degrees, right? It doesn't understand degrees. The degrees are all done in radians. So you have to take pi and divide it by 2, or 0 pi for east and so on, right? Depending on where you want the position to start or to end off, or where you're pointing, and from a compass perspective, this would be north, pi divided by 2. This would be south, 3 pi divided by 2. So as the wheel turns, okay? So here's where we drew a series of lines, and each point was a tuple. So the points is actually an array or a list of tuples, like we talked about before. Okay? Polygon. Here's something that I want you to talk about a little bit too. There's this idea of anti-aliasing. Okay? So anti-aliasing makes smooth lines, like smoother appearing lines, right? Let's take a look at that as a close-up. So if you notice, here's the normal non-anti-alias line, right? And here's the anti-alias line, how it adds in these other colors to make it look like it's smoother, right? So this is going back to basic graphics. I don't know if you guys have ever studied this kind of stuff before. Yes?
Yeah.
I'm just kidding. I don't know if you have or not, right? But this kind of idea, right, if you draw a line in Pygame like this, it'll look really ugly, right? Like an actual line, not freehand drawing, right? Here, if you draw it like this, if you use anti-aliasing, it'll actually look smoother, but you're going to add in additional information, to fill in the line a little bit. And there's actually a function that uses this AA line function, this method, that creates an anti-alias line, okay, as opposed to that ugly single line. So here's two different functions, the line function, and here's the AA line function, the exact same effect, but or the exact same lines, let's say, but a different effect. Now, sometimes you may not want to use anti-aliasing because it takes away accuracy when it comes to drawing, right? It does make it look smoother, but you may not want that.
The line's straight. You need a. I mean, straight up down or straight.
No. For the diagonals, it makes sense, right? That's where it takes effect. In fact, if you use a straight up and down line, if you ever do exactly straight up and down line, there is no anti-aliasing, right? It's only when you go on an angle that it does that.
Use the AA line and do the straight up and down line. Would it still color in on the sides of it, or would it just not do anything?
Depending on how straight it is. If it's perfectly straight, no. Right? It's the line width that you specify, right? But if it's on an angle, yes. Right? That's where it would go. Okay, we talked about getting mouse data. So this is this mouse position that we talked about before. So we've kind of covered that. Okay. Here's importing a limb image. We talked about this already with the paint.py program with this image.load function. Okay, now it says the image can be JPEG, a BMP file, a GIF, or a PNG, right? And that's the advantage of Pygame over something like Tkinter or whatever. But I warn you that not all JPEGs, bitmaps, GIFs, and PNGs are created equal. And what I mean by that is sometimes you may want to load an image in your game, and it's going to error out. It's going to say, "Meh, I don't understand what this image is. Why are you loading this image?" Because the image might have other background information it's not a simple bitmap, or it's not a simple PNG. For example, it might be a PNG 8 or a PNG 32 or whatever. And depending on the type of PNG file you use, it may not be accepted properly in Pygame. So beware. Take a look at the image. Try different images out before you say, this doesn't work, and throw up your hands. It may not be your code that's not working. It may be the image or sometimes the sound file. And when we go into sound, it doesn't work.
If you do have that file, you can just open it up in Paint and then resave it as a
Right. Yeah, that will work. Right. I mean, you can, and that's where I say convert the image to something that might be better readable by Pygame. Okay, so if I look at face.py, we've already covered this, but let's just quickly look at face.py. And all this does, it doesn't work. That's what it does. But it loads up a face. That's what this is supposed to do. It loads up a face. It's called Andy.jpg. And the reason why it didn't work is because I don't have that object here for some reason. I've lost it. Because it's trying to load an image, Andy.jpg doesn't exist. So I'm just going to load in something else. I'll load in reset.gif because I have that. That's why it didn't work. There we go. Okay, on a yellow background. Okay, so again, the way we do that is we use the image.load method to load stuff in. Okay. And the same thing with saving an image. Okay. Now it says save to BMP or TGA format, right? And And that's the challenge. If you want to try and save it to some other kind of format, that's where it doesn't quite work the same, right? So here, let me just pull this up. And if I run it, it doesn't show anything, but it actually produces this circles bitmap. So if I go back into Fireworks, okay, I'm going to close this stuff off. And I'm going to pull up circles. Here it is. This is the code. This is what it actually generates. So there's an algorithm in Pygame that generates this, right? And it's using the different functions here to draw different circles in a loop. Okay, so from 320 circles basically is what it's doing, right? And then it's saving that image as a bitmap. Now, if I tried to save this image as a PNG file, right, it may not work as you think, right? So my recommendation to you is if you're going to save images, it's okay for assignment number 3, to save them as bitmaps. It's okay. I'm not going to make, if you want to explore saving it in other formats, like for example a TIFF or a GIF file or anything else, I would give you additional marks for that, right? But right now, the typical way of saving things is a bitmap.
What would happen if you save it as like a PNG?
I knew you were going to ask that question, that's why I kept on hovering there. All right, so it does whatever it's going to do. It's creating the BMP. Here's the PNG file that comes up, right? The problem with it is, I know, you're curious. Problem with it, and by the way, this has changed because it's the same thing, right? Different iterations of the code has come out since. This is a PNG32. Okay, that's the default format that it creates, right? And let's take a look at the original image. Okay, it looks exactly the same. One is BMP24 format, and the other one is PNG32 format. But my recommendation to you is in previous versions of this code, this won't even work. This has been updated, remember? In Python, right? Python's gone through different iterations since this book was written. Python was written in 2.4, the book was written in, and Pygame was at a much earlier version, 1.7 I think it was. And now we're at 2.7.5 and 1.9.2, right? So things have changed since the original book was written. But what I'm saying is, when you have a dialog, for you to make a dialog box to save in different formats, to give you option, I'm saying, not just save in one thing, a PNG or a BMP, right? But different kinds of formats, that's where you'll get the bonus. Okay? All right. So we created a text surface, and that's where that font came on. We saw that already, right? So that's a label, really. That's what it is. And show text.py. I'm not going to go through this one because it's using a system font. That's what it's actually doing to build that font out. You can go through this on your own. If you go to show text.py, it's not very exciting. That's why I don't want to really show it. I'm going to basically make your eyes glaze more than they're glazed already, like I see, right? Custom fonts is cool. Let's do that one. This one's a little better because you're going to have to do this for your game, right? Your custom font. Okay, so we are going to make our custom font here. My label is the code that I'm using. My font, I'm actually going to load. I'm going to use the font methodology in class, right, to load up something called Gringo Nights. You can load whatever true type font you want in here, right? And I'm actually going to make it 40 points. So it's quite big, right? And I'm going to say Python in the Wild West. That's what Gringo Nights looks like, yeah.
In this case, Gringo Nights have to be in the folder that is in.
Yes, very good. Or you can specify another folder by using a different path. Okay? And I recommend that. I recommend that when you're building your game up, what you do is you make your asset folders separate. So that way only your Python file is in the main folder, your .py file. And I'm talking about what you may want to do is if you're going to hand in your final project, and I'm digressing here a little bit, but what you may want to do is say, here's my final version of my code. whatever it is, .1 or .1.2 or whatever it's going to be, right? And then you have another directory or folder in your project that you call versions or previous versions or backup or old, whatever you want to call it, right? And then there's where you put in all the other versions of your code. You just kind of send it in there, so you're not working with those versions anymore. You're leaving them alone, right? It also helps from a confusion perspective, because if you have them in a different folder, you're not going to touch them by accident, right? And then you have another folder called images, and maybe another folder called audio or sounds, right? And if you do that, you break your code up so that, or you break your folder up so it's more, again, human readable. So it's not jumbled in. You don't have like a bunch of different images and stuff all in the same folder, and then I'm trying to find your executable, right? That's not cool. Okay. So again, if I run this, you're going to get Gringo Nights, Python, and the Wild West. I'm using a custom font here, right, and I'm loading it in. Now, I should mention this style of loading in fonts, your TrueType font into a game, is very common. You know, again, I've known that I've heard that other people can use games, especially if you're connected to the internet, because remember, Python it works well as for web development as well. You can use it for that as well. It's not just for programming. And I've heard there's modules that you can link in for web fonts if you really want to do that if you're connected to the internet. Don't recommend it for your game, but if you really wanted to go crazy, there's a whole slew of fonts you can get. Or if you can steal some I'm going to use that term lightly. You can get fonts that are in your directory, like for example that are part of your Windows load, or through Adobe or whatever, and you can use those fonts as well. So for your game, my recommendation is you use some custom fonts so that it makes more sense. It's more applicable to the type of game that you're doing for your final. Okay. So we talked about basic events. We're not going to respond to joysticks, right? Because we're not going to use that type of controller in our game, in our situation here. But we're using this pygame event.get to check every event that occurs within each frame. Now, depending on when you actually check. So this pygame event.get's got to be within your game loop. Or if you only check it once outside of the game loop, you'll never check it again. It's got to be within the frame, in the game loop, and it's going to be checked every frame. So if you set up your game so that it's 30 frames a second, it's going to be checked 30 times every second. It's pretty fast, like for us. 30 times a second, it's going to be checking for different presses or whatever, which is pretty good. And like I said, most mobile phones and mobile devices right now are 30 frames. Although I'll be honest with you, the reason why I missed last week when I went to the BlackBerry conference, they claimed that their device, their BlackBerry Q10 and Z10, can handle 60 frames a second, right? And it's true because it uses C++ as its background, right? So, I mean, we are moving forward, and we are able to handle faster speeds with mobile devices. And one day, I think this whole conversation will be moot. You could make your games work at 120 frames per second and make them even more sensitive, right? But right now, I would recommend to you to be platform independent to stick with 30 frames. Okay, so we're checking key presses. We've done this before, and I showed that, and we've gone through this stuff in the code itself. Let's look at lines.py. This is something you can add in right into assignment 3. This is something that will help you right away. Okay, and there's actually the next one's even better. So here's a line. I'm going to draw a line. There we go. If you notice how there's a delay, so I go, here's my start point. I'm going to drag, and here's my end point, and let go, and it's going to create my line. I can't vary my width, my thickness, or anything else in this code, right? But I'm able to draw lines specifically.
Do you guys render what it looks like before you let it go?
Yes, I'm going to show you that in the next one. That's a preview we can do. All right, and there's a way of doing this, a trick. So if I do a bunch of lines at once, right? If you notice, there's a bit of a delay because it's trying to draw the lines all at once, because even it's chugging, right? It's trying to do that. How do we do it? It's right here. Line start is my mouse button down position. Line end is my mouse button up position. It's going to take those that information and draw your line. And it's going to draw a anti-alias line with width of 3. Right? Pretty straightforward. Okay. If I want to do a line preview, that's the next one. Okay, I'm gonna go through this in a second. All right, so here's my line preview. This code does exactly what you're saying. If I hover over it, it actually shows me the line. Right, this is the kind of stuff you want to do with your rectangle. You want to do this with all your stuff. So before you actually let go of your tool, before I let go of I do a mouse button up, it allows me to continue to draw my line, but it does it in the way that it erases it and redraws it every frame. Okay, so as I move it, it's actually erasing and redrawing and re-updating my surface until I let go. When I let go, it actually releases it, puts it in the exact width that I want, and leaves it in my surface. Now I can't fool with that anymore. Right? It's not an object that I can fool with. But if you notice, I have the control for every time I draw my lines. Okay? So how do I do that? A little bit more complicated code, but not much. Right? So again, in this particular case, if my event type is mouse button down, I get my line start. My preview, I have another flag that I set up called preview is equal to true. So I'm actually previewing my line. My mouse button is still pressed down at this point, right? And then when I mouse button up, my line end is equal to my mouse button position, right? And I draw my line, right? My line end, my final line, and my preview is false. Else, if I've got my mouse down, I've already responded to that event, right? So I set up my line start, and I set up my preview to true. But else, if I'm just moving my mouse button around, and I haven't let go of my mouse yet, right? That event hasn't stopped, right? I've got my mouse down. I've already activated that event, right? Now I'm using my mouse motion event. I'm listening for mouse motion, and my line end is going to continue to change according to my mouse position. Okay? So the trick is, right, I'm in a loop where I'm going to continue to update my line position, right? And I'm not going to stop. I'm not going to like let it go. Here I am. I'm not going to let this go, right, until I actually let my mouse button up. Okay, but now this is in the same while loop. Here's my game loop here, right? I'm going to update my screen. Here's my screen. Every frame. So I move my mouse. I'm going to update my screen. And then if preview is equal to true, I'm going to draw my line right now with a width of 1, wherever it is, right, in this particular preview. So example this, first frame. I move my mouse around. It draws my line where my mouse is supposed to be, right, here. And then when it goes back to here, it's going to check, did I move my mouse or did I do any event? If I have, right, if I move my mouse again to another position, it's going to redraw it in that new position, right? And it's not going to let it go. It's going to keep updating my line and keep drawing my line all the time, right? That's what this is going to do. And it's going to keep on moving it until my final, until I let my mouse up. Okay, that's what this is going to do. Yeah.
Does this little program you have here have like a Control Z or an undo function?
I didn't ask for that, but no. You could do it. You could do that. Huh? Yes, absolutely. How would you do it? Yeah. Keep track of what you do in a list, most likely. So basically what you do is you do a command, right? You keep track of your start and end of that command and the previous state. Sometimes what some programs do is they keep track of the surface object. They save it somewhere. Whoop, it's saved automatically, right? And then when you undo, you load that back in. That's a nice, easy way of doing it, right? Tricky way. You undo, you just save your previous image. And you have your previous image in a temporary directory that you keep going.
Well, like when would you save it, though? How often do you save it?
Every time you make a change.
But as soon as you make a change, you can't undo.
No, you make a change. When you undo, you go back to the previous image.
So you need two then.
So basically, if you check to see if there's you check your directory to see if there's a previous image, right? And the way you can do, you can timestamp it. There's different ways of doing it. Or you can hold it in memory. So don't save it at all. You hold it in memory, the surface object, right? You throw it into a temporary slot in memory, and you might have an array of events, right? That you keep a track. You keep track of an array of events, and that's why, if you notice, even later on, Adobe only keeps track of so many events, and then you can't undo anymore, right? Because you've gone beyond its memory capacity. It holds all this stuff in memory, right? Yeah, so an undo, yeah, I would definitely give you a bonus for that one. Okay, but to be fast and dirty, save it to the computer somewhere and then load it back in again. If you want to do it that way too. There's many ways to kind of, to do this kind of thing. It's just the way you think about it. It's all creativity. Going back to what Haley was saying, creativity. All right. So we talked about this. So again, the paint.py strategy, we looked at this, right? The mouse draws on the screen, the keyboard changes the color and the pen size, and now when you do your assignment number 3, right, I'm going to ask you to remove your keyboard controls. I'll say that again. Remove your keyboard controls. I don't want to see keyboard controls unless they're accompanied by, I'll say it like this, an icon or or some kind of button. And the reason for that is if you give me back the same file, paint.py, and it's exactly that allows me to do that stuff, you're going to get 0. I won't give you any marks for that because I'm just spitting back out the same code, right?
I had one question. If you do a supply game, and you have 2 services, and one is obviously your buttons, and the other surface is where you draw, like you were saying.
Yeah.
Would it draw onto the other surface?
No.
Go this way, or would it automatically have to go that way?
Well, no, it would stop. You could continue to draw off the screen, but it wouldn't draw anything. It's almost like when you have a surface, yeah. So let's say, for example, and that's a good question. So if you had 2 surfaces, one for your buttons and one for your screen, and let's say this is like this. Instead of 2 surfaces, let's make it 3, just for the sake of an argument, right? You make one surface that goes to here. Here's your sidebar. And you make one surface that goes to here for some common controls like loading and saving and stuff. This is the common way we do Windows. For Windows apps, we do it like this, right? We have our load here, you have your save here, and different buttons on the top of your surface. And here you have all your controls that you have for your drawing, right? So these 2 surfaces are only for those buttons, right? They're going to receive commands and only in those surfaces, right? But in here, and this canvas here, this is the only area that your drawing will work. This is where it's going to blit to. This is what's going to update. Your buttons aren't going to really update. They're going to stay the same, unless, of course, you make them so they're animated buttons, like they have hover, functionality. And that way you're listening for a hover over event, like some kind of, I'm moving my mouse over the button. And when I do that, then I, as an example, I change the button to look like something else until it's pressed. So there's two different states, if you will.
So in the game loop, like right for the first one we just did the slot machine, you would do screen.lit, or what was it, screen?
You're updating the screen at the
one surface, so if you want to do both, then you just
No, the screen.lit updates that. Screen.lit does the screen is your window, right? Background is your surface, right? So at the end of the day, again, your background is a surface object, so it's a surface container that's inside of your top level window, all right, or your screen in this particular case. And I'm not going to go through this, but this is going to go through the paint.py in a lot more detail. It's going to talk about how it does check keys and show stats and everything else, right, which we've kind of already done. Okay? So, again, recommendations to you for assignment number 3, before I let you guys go, right, for the day, is think about how are you going to design your assignment number 3, okay? And I'm going to, if I'm setting this up for the first time, okay, so this is me, I'm setting it up for the first time, how would I come up with setting this thing up? Am I going to do this in Pygame? Probably. Can I do it in Tkinter? For sure. I can do it in Tkinter in 2 seconds. All the functionality for drawing and everything else would work great on a canvas object in Tkinter if you felt like doing it. Can I do it in PyQt? Definitely. I could do it in that for sure. Probably I'm going to do it in Pygame though. And how would I set it up? I would probably do something like this. My first drawing for my wireframe is going to be done like this, okay? And my recommendation is you use some kind of tool for your, and Haley, I'm not sure what you're using for your, because she's, Haley's the graphic artist of the group. I'm mentioning her name for that reason. Here recorded for eternity on YouTube. But if you look at the different tools we have something called, and I'll let you go with this thought, something called Wireframe Sketcher. All right, that actually exists. That's out there. Or Wireframe Sketcher Studio is what it's actually called. Now, there is a trial version you can download for Eclipse. All right, there is, if you wanted to. It's a plugin for Eclipse, and actually, it is using the Eclipse framework. What it allows you to do is draw objects, a drag and drop framework to draw sketches. So here's an example of a sketch that I've created with Wireframe Sketcher right here, right? So this is the whole object. So what it allows you to do, right? If I actually look at this stuff, if I delete these objects here, it allows me to create quick wireframes. That's why I recommend it, or something like it, very, very quickly, right? And save them to a compatible program. So compatible program can use it. So again, if I want to use a browser, or if I'm using if I'm looking at different kind of containers, as an example, I can create a panel. So here's my panel. I'm drag and dropping a panel. I can resize it, right? And this is my panel. This is what I'm actually doing a sketch of what my code is going to look like. Maybe I want to put another panel in there, right? Here's my window, right? Maybe my window object is going to be the top level that I want, right? And I can layer them the way I want. I can bring this to send this to back, where I can arrange it so I can send it to back. Or here we go. Here's my panel, right? So this is where my background is going to be. I can create another panel that maybe looks like this, right? So just kind of to describe what my screen is going to look like, right, and so on. My recommendation is you sketch out your code first. You kind of plan out what your screen is going to look like before you do any coding whatsoever, all right? And you use something like Fireworks or GIMP or Photoshop or whatever you're comfortable with from a graphics program to define the view, whatever you're going to look at. And when you create your external documentation, you've already done your sketches. Your sketches are the stuff that you're going to be using to create your app, whatever it's going to look like. So you kind of do all your wireframing right here. And this is just, again, Wireframe Sketcher is the program that I'm using. But you could use many other ones. There's tons and tons of them out there. Here's another panel, right? So here's I'm just going to quickly draw this out with the last remaining minutes of our class. Actually, I probably don't want it to be this high. I probably want it to start down here. And I want my actual, so here, up here, and now you can define these the way you like. You can label them and so on. So this is what my window is going to look like, rough. And here's another panel. This is where my canvas is going to be, right? So I'm going to kind of define my canvas. Right? So here's what my canvas is going to look like. This is the top level of what what it's all going to look like, right? And I can use buttons. There's different buttons for not just layout, but input and widgets and containers and so on that allow you to drag and drop stuff in here. So if I want to have a button, I can put my buttons up here, right? And I can label them the way I like with Wireframe Sketcher, right? So here's my button and so on. And I can sketch out the exact way my interface is going to look.
You can't plug that into a can?
Yeah, you can.
I think
Clips on Tamna, same thing. The challenge is it's only a trial. So I think it expires in 30 days, which kind of sucks. Right? So that's what I'm saying. Huh? No, I don't think you can. So my recommendation to you is you get an external piece of code like Wireframe Sketcher Studio. And again, you can download trial versions for sure, or you can use just like this. You can just draw freehand like this inside an application like Fireworks, right? Where you draw this stuff out, you plan it out, and then you produce it in your external docs. Paint's fine too. Okay, guys, that's it for me. I'll see you guys next week, and I'll throw up these videos later on today.